Today we are doing Notes 3.1a. So this entire unit is about what we call polynomial functions. So poly means multiple. So we've had quadratics, we've had cubics, we've had linear, but now we're going to get into like x to the fourth or multiple terms. So we've seen polynomial functions before. Y equals ax squared plus bx plus c. That is technically a polynomial function. It has a name we call quadratic. So the leading term of a polynomial is the term of the highest degree. So the leading term for the polynomial is 5x cubed because it has x to the third. The leading coefficient of a polynomial is the coefficient of the leading term. So in this case, it would be 5. The exponent is the degree of the leading term. So in this case, it's to the third. So it's a third degree polynomial. So example 1, name the degree, the leading coefficient, and the constant term. So the term with the highest degree would be 6x to the third. So this would be a third degree. The leading coefficient would be 3. The constant term would be 1. So constant means it doesn't change. So in this case, the 1 will always be 1. The first 3 terms all have variables, so they can change depending on what x is. So you have your leading term, it's third degree. The coefficient is leading coefficient 6. Not sure why I wrote 3. And the constant term is 1. And again, the main reason we're going to start to do this is when you start looking at the degree and the leading coefficient, that's going to determine what we call our end behavior. We're going to get to that a little bit further down in the notes. Okay, example 2. Name the degree, the leading coefficient, and the constant term. Now, example 2 is in what we called factored form. Example 1 was what we called standard form. So factored form is a little bit more challenging. So notice we got the leading term, right? It's the one with the largest exponent. So where are we going to get the largest exponent if we had to multiply all this out? Well, it would come from the 5x, the 3x, and the 2x squared. So 5x times 3x times 2x squared, that would give me the leading term. Why? Because those are going to give me the largest exponents. Those terms, if you multiply together, that's where I get the largest exponent. So it would be 30x to the fourth, right? Because you have x times x squared. So the leading coefficient would be 30. Now, where does the constant term come from? Right? Well, it's going to come from the 1, the negative 1, and the 5 squared. So 1, negative 1, and 5 squared are going to give me the constants, because if you multiplied everything out, eventually all the constants would be multiplied. So that would be the constant term, so would be negative 25. And this is a fourth degree, because that's a 4. And again, the negative 25, if you were to sit here and multiply all of this out, right, eventually that 1, negative 1, and 5 squared would eventually get multiplied together, and that would be your constant. Or you would eventually combine like terms, add them together. That eventually will be your constant. So that would be the negative 25. So you're going to see that in terms of factored form, it's going to be a little bit more challenging to get the degree. And why am I asking about the constant? Well, you're going to start to realize that if you know the constant, you actually know the y-intercept. Okay, so I already graphed these for you. So make sure as you're going through, you're sketching them. So I have them already sketched. If you want to use Desmos to check your work, I would encourage you to do that. But I already used the graphing utility. Right? I used Desmos and I already graphed these for you. So what is the highest degree term? 3x to the fourth. It's a positive coefficient. Is the degree even or odd? So I'm looking at the 4. So this would be even. Remember, the degree is the exponent of the leading term. So that would be 4. Okay, example 4. The highest degree term would be 2x to the fifth. It's a positive coefficient and it would be odd. So as you're going through working on this, make sure you kind of start looking for some patterns. Look at where the graph starts. Does it start high or low? And where does it end? High or low? And see if you can start recognizing a pattern. There's a number of different patterns. Okay, next one, negative 2x to the fourth. So the coefficient is negative and it would be even because that's to the fourth degree. That's the exponent of the leading term is your degree. That's basically the largest exponent is what your degree is. All right, go ahead and flip your notes over. Okay, again, I sketched example 6, 7, 8. I used Desmos to create these sketches. So look for the highest degree term. That would be negative x cubed. It's negative, and it's odd because this is a 3. Now notice, where does this graph start? Well, it starts high and it ends low. Well, if you go back here, example 4, because that was also odd, that started low and ended high. So they're opposites of each other. Well, what's different? They're both odd, right? So again, looking for these patterns. Okay, example 7. Now, be careful. You want to say that 2x to the third is the leading term, but no, it's not. The highest degree term is 3x to the sixth. So it's positive and it is even. So positive and even. Oh, there's another positive and even. Example 3 and 7. Oh, they both start high and end high. I wonder if that's some pattern. Okay, and notice on here I have a couple of these points marked in black. Negative 1 happens to be the y-intercept. Positive 2 is the y-intercept. That constant value is your y-intercept. If you know that, and when we get to the graphing later in the unit, it makes it a little easier. So this would be 5x to the fifth, positive and odd. All right, highest degree term, negative 3x to the fourth. There's only one. Coefficient's negative, and it's even. Well, notice, look at example 9 versus 7. Because they're both even, but one's a positive coefficient, one's a negative. And look how they're different. Right? Where does a 7 start and end, and where does 9 start and end? Right? They're just opposites. Again, minus just means opposite. So if you go up, for the positive, opposite of that would be going down. So the main thing we're trying to take care of is this little end behavior here. We want to be able to use this to basically put the pattern down. So looking back at the ones you just went over, if it's an even function and it's positive, so like example 7, what's the end behavior? Well, it goes from high to high. So anytime your function is even and positive, I know the graph's going to start at positive infinity, do whatever it wants to, and then eventually it'll go back to positive infinity. Well, what if it's even and negative? So look at number 9 right here. So that would be low to low. And you're thinking, well, that's kind of hard to remember. Well, also think about minus means opposite. So what is opposite of high to high? Low to low. Okay, so even functions start and end in the same direction, right? Both of them either go high to high or low to low. They start high, end high, start low, end low. So even and odd, I mean, they're not technically opposites, but like if you were thinking about it, you could probably argue, okay, even number, odd number, those are kind of like opposites. So if even start and end in the same direction, odds are going to do the opposite of that, which would be start and end in opposite directions. So let's look at an odd positive. Look at example 8. It starts low and it ends high. Right? The graph is starting down low and then it's ending up high. If you look up at example 8, starts low, goes low to high. So what would be opposite of low to high? Because that's what odd and minus means. It's opposite of positive. So that would be high to low. So let's find an odd and negative. Oh, look at example 6. It starts high and it goes low. So that would be an example. So that little table there kind of reminds me of like a Punnett square from biology, is end behavior. That's going to be very useful. You're going to use that a lot in this unit. So that's something you want to basically memorize. You want to be able to just draw that right away. So anytime I ask you about end behavior, that's the little box I'm going to reference. And you just want to start writing it down over and over and over, so by the time test comes, you already have it memorized. Okay, so we're going to identify the end behavior and justify it. So again, I already sketched this graph out using Desmos, but if you want to go and double check, you can. So the end behavior, well, let's figure out would be negative x to the 5th. So it would be odd, and it's a negative coefficient. So it's odd because it's to the 5th degree, and it's a negative coefficient. So odd and negative means the end behavior would be high to low, which is what it is. So this is your justification. Right? Again, it comes back to just using that little box there. So I'm going to use that rectangle a lot. Right? I'm going to reference that over and over and over, rectangle, square, whatever you want to call it. So you really want to understand the end behavior. Again, you find the term with the largest exponent, that would be the degree, and then you look at the coefficient. Is it positive or negative? So when you're done, right, again, on all these graphs, I didn't expect you to be able to sketch it perfectly. Again, I just used Desmos. So make sure as you go back and you're looking through these notes, understanding, right, to find the degree, it's the largest exponent. And then you look at the coefficient of that term. Please make sure you answer your essential question as you're writing your summary. And then you'll be done with your notes.